Hello, I'd like to talk some about Wireshark and a TCP session. So I ran some information just a little while ago, and I'm just going to click on one of these places. I think this will get me what I want, and I'm going to do an analyze follow TCP stream. Now this is just not readable. It should be, but it isn't. But this is what we want to look at. We are looking at a particular stream. This is everything that happened in one of my sessions with one place. Now I am 2600 8805, and this other one, I think, if I'm correct, is the Weather Bureau in Taunton, Massachusetts. So one question I would ask right off the bat is, where is the three-way handshake? It turns out the machine helps a lot on that. So you're going to get a homework. One question will be, where is the three-way handshake? Point out to the frames. Well, here you'll notice there's a sync ACK, and an ACK. You'll also notice that no data has been really transferred. The sequence is still 1. So nothing has really come over, just command messages back and forth. Now, we go on, and there's a gap here, 3614. And if we go down a lot further, way further, this was a long session. I have to get out of the TCPs to show you what I want. I may never get out of them. Now let me keep at it. I know it's there. I saw it a while ago. As I said, this was a very long... There's what I want. Now I want you to notice in the TLSs, I want you to look for the TLS handshake. The TLS handshake tells us about the what we're going to pass in, what kind of information. It's involving the security, the coding, the encoding. It's a client hello, a server hello, and the ACKs back and forth. It's actually a 4-way handshake. But I want you to notice this happened at 3610. If you look way back at the beginning of this, if you go up above 3610, I would love to get up there. Here we are. You notice that's the break between 3609 and 3614. And if you'll notice, the data starts coming after that. Maybe that has something to do with doing the TLS before the application data comes across. So you might look into that when you're doing the homework. Also, I want you to look at the sync ACK, I believe it is, down here. I want you to look at the options. You'll see an option, SAC permitted. That stands for selective acknowledgement. You can look it up easily on the internet. I did. It reminds me of a particular algorithm we were talking about. In fact, It was used in the last homework from the Kuros-Ross type homework. So see if you can figure out what that one is and read about it and see what it says is possible. Also, there's a window scale option. What is that all about? Look that up on the web and see exactly what that means. It has to do with the size of the window. We want to be able to send very large amounts of data. But the area we have to describe how big our window is doesn't have enough bits to really put in the size of the window we want to send. So to handle that, we don't send the actual window size. We send the window size and tell the other side to multiply by something to get the real window size. And that's what scaling's about. It tells the other side, the server, how much to multiply what seem to be our window sizes to get the real window size. Also, there's a lot of no-ops here. Why? They don't do anything. If you look up what it says about options when you talk about the TCP, you'll find out that there's a reason. It has something to do with size. We can't always have very small things in certain places. Sometimes we have to make them large enough for various reasons. So perhaps the no-op has something to do with that. Now let's see if there's anything else in here I want to talk about. Again, the flags are there. You can see them. And there's nothing else here that I want to talk about at the moment. There's a lot of windows here. And some of them have a push and some of them don't. What does the push mean? What does it tell the client to do? I'll give you a hint. Most of the pushes are on the reassemblies of parts of a segment. They're when the whole segment has been put back together again, when it has been transmitted in pieces. What do we want to do with that segment once we get it? Once we get all that information together, do we want to hold on to it, or is there some place we want to send it? Think of that. Then, there is way down in the end, usually it's right almost the end of the TCPs. I wonder if I can do it this way. Yeah, that's faster. At the end of the TCPs, I think that's where it was. I may have not seen it there. This was a long transmit. There it is. Gently up. Yeah. Notice the fin ack and the ack and back the other way. What is this doing? Pretty good hint that it's at the bottom of the whole thing. So maybe it has something to do with stopping everything. Now, I'm giving you a different one of these captures. In fact, I'm giving you the one that's already out there for your homework. In that particular stream, things don't end as well. They end more abruptly. And you might have to look at the last one there in terms of time and see why it ends, but it's not a nice orderly ending as this one is. Because this one, both sides agree that they're finishing, and both sides acknowledge the other side. That doesn't happen in the stream that you're looking at, unfortunately. So you'll have to take a look at that. Now, for this homework and for all of this, you need to be able to go to the Google and look at certain places to find out what's going on. More and more as I dig into Wireshark, there's a tremendous amount of stuff there. And the TCP is quite comprehensive also. TLS, by the way, is one of those protocols that doesn't fit in the nice, neat model that the International Standards Group want to give us. It just seems to fall into 3 or 4 of the layers. But that's just the way it is. TCP/IP does not make any attempt to obey the layer restrictions in the international model. It just does what it wants to do. Remember that TLS is a sort of an add-on protocol to TCP. It can also be added on to other protocols. And what it is the way to get security. If you look at the client hello in the TCP, you will see on the transport layer security, you see something called record layers, and you'll see that this is the handshake protocol. And then there's a lot of extensions that are here. What this is the client saying what kinds of security methods it would accept. When you see EC in here, it usually means elliptical curve. Elliptical curve is the next frontier of the key security. We've been relying on the RSA algorithm, which is named after the 3 people who developed it. But with quantum computing approaching, the RSA is not going to work much longer. Even now, the computers are getting so powerful that to make RSA work, we have to have bigger and bigger and bigger primes. So the math world, and the CS part of it that is very close to it, more theoretical, they're working on a different set of encoding methods that use a function called y squared equals ax cubed plus bx plus c, with different a, b, and c's. And we'll talk about this some later, but I just want to point out to you, that's what the TLS is all about. It's the different kinds of things we can use. Talking about, and you could look at what each one of these mean. I'm not going to worry about that at the moment. But, for example, there are 16 cipher stream suites. These are different algorithms that are used. See, the RSA is here. And it's got an extension. And there's ECs here also. So there's different ways of encoding. That's what that's all about. Now that's all I want to say now. I'm going to put out this particular capture, and the capture that you're doing for the homework is already there. The captures will be under the homework section. So take a look at it. I think on Monday, or maybe even on the weekend, I'm going to do another section on Wireshark, and what I'm going to be talking about then is the statistics area. It turns out there's a lot of things we can discover under statistics. It's not very hard to do, and it's not the kind of statistics that is going to take you into some actuary business. It's pretty mild. So we'll look at that. But right now, I'll work on the homeworks you have and see what happens. So long, and have a great week.